Looks like we're live. Hello everyone and welcome to another Zoom session. How about that? But you didn't expect that shit to happen, so let's make a little bit of an announcement on Discord server. And of course, officially start the stream. So, this is gonna be a red circle live on Twitch, and today we are improving the syntax of my language in Rust. Specifically, I'm talking about Nock, which is a programming language for like mathematics, rather for transforming algebraic expressions, and I think today is the day when I try to improve its syntax, because the current syntax is sort of like a placeholder, right, and it's not particularly, you know, ergonomic or useful. So http twitch.tv/Zoding, and I'm gonna ping everyone who's interested in being pinged. So essentially what we're doing today we're bike shedding, right? So today we're doing everyone's favorite activity, arguing about different names of different keywords and stuff like that. Hello, Morgan++, hello, Seek1337, Thomas, Nihlete, I don't know how to pronounce your name, I'm sorry. But hello, Legamegar, Benber, TFT3, hello everyone, welcome. So let's take a look at the current state of Nock. Right, so the idea of Nock is that it's like Coq, right? So the proof assistant, but it's actually not Coq, right? It's not trying to be a proof assistant, it's not trying to be, you know, mathematical and like really formal or rigorous. It's basically the algebraic expression transformer, right? So, and you can use that transformer to sort of like demonstrate a proof, not to actually prove anything, but to demonstrate, like mechanically demonstrate the proof, right? So it's not meant to replace Coq in any way. It's just like, you know, mechanical substitution of the sub expressions. Sorry, thank you so much for 13 months of Twitch Prime subscription. Thank you. So yes. And currently language looks like this. So before I show you, I'm gonna actually fetch the latest changes, because we have quite a few changes. And I'm gonna merge everything into the master. So yeah, we finally have a standard library, right? So, and in the standard library we have this kind of stuff. So I have definitions for some of the numbers, right? So I have some of the axioms, some of the theorems sort of predefined for different operations like plus or multiplication and division and stuff like that. What's cool is that I recently implementing defining rules through shaping. Right, so for instance, in here you have a plus b squared, right, and you can sort of like prove that a plus b squared is equal to a squared plus 2 multiplied by a multiplied by b plus b squared through a sequence of rule transformations. And once you demonstrated that, you can create a new rule specifically for that. So that's what's cool about that. Right, so because you can basically take the initial expression and then the final expression and sort of form a rule out of that. Right, you can form a rule out of that. I can probably demonstrate that. So I'm going to go ahead and comment out this entire thing from the standard library. Right, so did I actually do that? Okay, so I'm going to go to Nock, right? And I'm going to do rl wrap cargo run. So that should build everything and start the repo. Have you read Hack Mem? I never heard about this thing, I'm sorry. Element0216, thank you so much for subscription, and Nico Red H, thank you so much for subscription as well. Alright, so I recently also implementing an ability to load files into the context, right? So we can do something like std nock, right? And that basically loads all of the rules from that specific file. As you can see, so I loaded everything, right? So which is quite convenient. So for instance, I can prove that I don't know, 3 plus 4, excuse me, shape 3 plus 4 is equal to 7. I'm not sure if it's a good idea actually, because we don't have a way to represent 7. One of the things we can do, we can prove that 1 plus 3 is equal 4. Right, so we can start shaping that. So as you can see, we have a rule 1, right, and I can basically apply rule 1 to the first match in here. So this is basically which match I should apply the rule for, and this is the name of the rule. You can use numbers as names for the rules, right? Because the language knows nothing about numbers. That's the thing. It knows nothing about numbers. It treats numbers as any character. It's just a label, right? So I create a rule with the name 1, which when it sees the, name 1, replaces it with S0, right? So it's basically piano numbers. If you never heard about piano numbers, I really recommend to check them out. Right, just Google it up. It's a very interesting concept. It is a concept that is heavily used in functional programming languages that are trying to validate their existence. They're trying to prove their usefulness for whatever reason, right? So, if you ever been in functional programming community, you probably heard about piano axioms, piano numbers, and stuff like that, because that's the thing that those languages are trying to validate their existence with, right? So they're trying to prove that they're useful, though quite often they prove the opposite, but anyway. So let me actually put that in the description. So piano axioms. All right. So, and basically after applying that, I have S0. So I can apply the rule 3 on the first match. I will get S2, then I can apply 2 and then 1. And basically I expanded all of the numbers into their sort of like piano representation. So after that, I have a rule that basically advances the sum a little bit further. I'm pretty sure I have the rule. Yeah. So basically, this rule will allow me to advance the sum a little bit further. So I can do apply 0 sum. And as you can see, it basically took S and wrapped it into like this sum. And in here, we can obviously apply sum ID, which removes the 0. So I can do apply 0 sum ID. Sum ID, and this is what I got. So I got 4s in a row. So here I can obviously apply the rule 1, so I can apply the rule 1, but I have to apply it in reverse, right? Then I can apply rule 2 in reverse, and then rule 3 in reverse, and then rule 4 in reverse, and as you can see, I just proved that 1 plus 3 is 4. Yes, that's how you prove that 1 plus 3 is 4. That, like, mathematically, technically, that's the actual proof. Yeah, so as dumb as it sounds, that's how you prove such thing. You can also prove that 2 plus 2 is equal to 4 the same way, actually. Can you code a recipe that works for all the available piano numbers? Not yet. It depends on what you mean by all of them, right? Anyway, so essentially what you can do, you can actually use a sequence of transformations as a way to define a new rule, right? So, and here's one of the things you can do. So we have the square of sum, right? And we start applying things. First, we expand the square, right? So that's one of the things we do. Then we expand the brackets in here, as you can see. Then we swap around the members a little bit, so we can apply another extension, like so, right? So it turns into that. Then we do a little bit of shuffling around with parentheses, right, like this. So basically we're trying to group these two things. Then I do a little bit of a commutativity, so to make these two things equal to each other. And then I can apply the double sum, and as you can see, I just collapse these two things together. Then I can take the rule for the square and reverse it, and that way I proved that the sum of the square of sums is equal to that. Right, but then I can say done, and as you can see, I defined a new rule. Through a sequence of transformations, I defined a new rule. So now, if I have expression f of x plus g of y, right, g of y, and I add it to the square, I can then apply this rule that I defined through the sequence of transformations, and it will work. There you go. So shaping is a process of transforming the expression, right? But then you can assign a name to that sequence of transformations and turn it into a new rule, right? So that's how it works. So, and the way you do that is by saying rule, the name of the rule, and then you start shaping and you define a rule through a shaping. Does that make sense? So yes, so that's basically how the language works, right? So I'm also planning to have nested shaping, so you can shape while you shape, so you can define like nested rules through the shaping as well. I think that will be interesting, but I'm gonna do that a little bit later. I'm gonna have a recursion, so you don't have to apply 0, reverse 1. Recursion implies a particular way of, like, it actually not clear what you mean by recursion. You know what I mean? It's like really not clear what exactly do you mean, because essentially you can define recursion like this. So you have a rule, let's call it rec, f of x is equal to s of f of x, right? So I defined f in terms of itself, right? I probably can do something like this, right? So I can take it like that. So it has to be a variable. Then I can start shaping and I say f of 69, right? And I apply the rule recursion once, then I can apply it one more time, and one more time. So it's already recursive. So you're asking, will it support recursion? It's already recursive. It's that you have to advance recursion manually, so it's not a correct question. You're asking incorrect question. There's already recursion. It's just like you have to advance it manually, right? So you see what I mean? It's just like it's not a correct question. So will there anything that will, you know, automatically maintain the recursion and stop at some point? Right, that's a good question, right? I'm still thinking how exactly, like, technically it's going to be implemented. I'm still thinking about that. So alrighty. How do you decide which rules are applied first? I don't know. When you are solving an equation or with pen and paper, how do you decide how to transform the expression? Like, how do you decide that at that particular point you need to, you know, swap the members of the polynomial around? Like, how do you decide? So it's the same thing in here. Like, you just decide. It's just your decision. You can do whatever you want. It's just like a, you know, it's an expression transformer. Intuition. Well, yeah. So this thing is essentially pen and paper on steroids. So it doesn't really do anything particularly magical, right? It's just like automates some of the error-prone things that you would have by using pen and paper, right? So when using pen and paper, it's quite easy to make certain types of mistakes, and these class of mistakes are kind of eliminated in here, right? Because you're treating expressions as a tree, and you transform in the tree, you pattern matching the tree, right? So. Pen and paper, we got it all, exactly. Something that we're not gonna have in Russia soon. Do you have an undo command? Yes, I do. We do have undo command. So essentially I can do something like shape 1 plus 3, right? Then I can apply multiplication commutativity, right? And then I can actually decide that it's probably some commutativity, right? So I decided that it's probably not what I want to do. I can do undo, and as you can see, it undid the rule, right? It just undid the rule. So my most common mistake on pen and paper is not to copy a part of the... Exactly! This is literally one of the reasons why I created this language. Like, literally, because when I'm working with very branchy expressions, like very big expressions, it's really difficult for me to keep track of everything and just copy everything correctly, because at some point I may forget something, and that error sort of perpetuates itself, and I end up with incorrect answer. So, and this is one of the reasons why I had really bad grades in math. Seriously, because I couldn't keep track of big expressions. It's not like I didn't understand how this entire thing works. I didn't understand the theorems, I didn't understand the ideas. I understood the ideas, I really liked like everything about math, but the fact that I had to do like this error-prone exercise that pretty much has nothing to do with actual math. Right, so this mechanical exercise has nothing to do with actual math, it's just mechanical transformations of expressions. The fact that I had to do that caused me to have bad grades on a subject that I really truly fucking love. So, and it's like so frustrating, and this is one of the reasons why like I had to create this kind of thing, right? Because I just can't do this mechanical thing. Phone 78, thank you so much. 79, thank you so much for 10 tier 1 subs. Thank you, thank you, thank you. And everyone who got the sub, welcome to Epic Knock Club. Oh, okay, so a lot of people can actually relate to that. Yes, that's the worst part of the school math, right? So they force you to do this boring mechanical error-prone shit and evaluate your knowledge of math based on that, which doesn't really have anything to do with math. Like, it really doesn't, if you think about that. And it's just so fucking frustrating. Like, it's almost like they're making fun of you or whatever, I don't know. So anyway, I always understand the concept and stuff, but often fuck up during the mechanical part of the transforming equations. Exactly, that's the same problem for me. That's the same problem for me. And you know who sort of win in this system? People who do not understand math completely and people who do not give a shit about math, but their brain is really good at just like this focusing on transforming things without even understanding them. That's the people who are valued by that system, right? The system is trying to teach somebody math, right? But it values people who don't give a shit about math. It's, yeah. So, anyway, I don't know. It turned into a rant yet again. All my streams turned into a rant. It takes an insane amount of mental effort and going over my solution like 10 times to make sure it didn't fuck up somewhere. Yeah, exactly. Exactly. Alrighty. So, what's the topic of today's stream? The idea of the entire language is cool and all, but look at this shit. Does the language look cool? Right. The idea of the language sounds cool, but the language itself, it looks kind of like a, you know, granny language. You know, so like Pascal or Ada or SQL or COBOL, the language with a lot of like English words, like old language, the granny language, right? It doesn't look modern, it doesn't look cool. I'm not saying that Ada is not cool. Ada is actually very cool, right? Like semantically, but I think the syntax of Ada could be a little bit more modern, but anyway. So, and it looks like one of those granny languages. So, and there's no particular reason why it looks like a granny language. The reason is because, for whatever reason, C, language won over any other style of syntax, right? So, if you think about it, C and Pascal were, like, appeared on the, like, in the programming industry pretty much at the same year, right, in 1970. But for whatever reasons, the C-style syntax is associated with a modern language, and Pascal-style syntax is associated with, you know, old language, right? So, even though they appeared at the same time, right? But for whatever reason, the association became like this. So, what I was thinking is that maybe we can turn this language into like a C-style language, right? That will look a little bit better. So sounds good. Okay, so let's go and take a look at some of the examples. So I wish I could just quickly do all of that. So we have some examples that prove different things, right? So this one proves the derivative, not really proves, but demonstrates what is a derivative of a square function, right? So essentially you have a function square of x, and x is basic basically squared. And also you have a definition of a derivative, right? So you take a derivative of a square, and through the sequence of different transformations, you demonstrate that x squared is equal to 2x, right? So that's basically what's going on in here. I can even show you. I can quite easily just run cargo run example derivative square, right? And as you can see, this is what we have in here. So we had a derivative of a square, and through the sequence of transformation, we end up with 2x. So, and thus we demonstrated that. And we used some of the rules that defined previously in the standard library and stuff like that, but, you know, ultimately this is what we managed to prove. So, what's the problem with the current syntax, right? It's really difficult to see where the name of the rule ends and starts the actual definition of this thing, right? So it's really unclear that this is the name and this is the definition of the rule. It's really, really unclear. So what I was thinking is that maybe we're gonna get rid of the rule keyword, right? And you define a rule by providing a name, a symbol, and then some sort of special, you know, separator, which separates the name of the rule and the definition of the rule, something like double colon, right? And that way you can define rules like this. So this is two definitions of the rules, and you can clearly see that it's a little bit more readable, right? There's less these keywords, and there's a clear separation between the name of the rule and the definition of the rule, and within the definition of the rule, there is a clear separation between the head of the rule and the body of the rule. Head is what we essentially pattern match on the current expression, and body is what we replace this head with. Given the variables that we also pattern match. So it looks way better. So we want to have something like this. Okay. So what do you guys think? What do you guys think about this sort of like definition of the rules? So shaping. How do we start shaping? We start shaping like this, and then we have a sequence of applications. Right, so to make this entire thing look like a C-style language, right, it has to be something that has like a curly braces, right? So what I'm thinking is that essentially shaping is going to start with the expression that you want to shape. And then after you provided the expression that you want to shape, you start the actual shaping. So open curly is going to indicate that you want to start the process of shaping. And if you want to end the process of shaping, instead of done, you're going to close the curly brace, right? So instead of like shape and done, we're going to have open curly and close curly, but to make it look more like a C, we're going to put shape after the expression that we're trying to shape. What's interesting is that we're not changing the semantic of the language, right? So none of the semantics of the language have changed, only the syntax, right? So I first developed the semantic of the language, and now I'm trying to come up with a syntax that fits that semantic and looks a little bit more modern, if you know what I mean, right? Why is there extra name? Isn't square, because the pattern, this is not a name. Head of the rule is not a name. It's an expression, because the rule, right, so something like square of sum could look like this. A plus B, 2 equal A squared plus 2AB plus B squared, right? There is no name in here, because this is not a name, it's a pattern, right? You match the pattern and you replace it with the body. So that's how it works. And then you use the name of that definition, during the shaping to apply that pattern, right? So for instance, I can shape, maybe I'm gonna do rule, swap, right? Which accepts A plus B and says that it's a B plus A, right? So I defined this kind of rule. Then I start shaping, I don't know, F of G of AB plus K, right? So I'm starting shaping this entire thing, and then I say apply swap on the first match of that rule. And as you can see, it literally just swapped two sub-expressions, right? I only defined these two variables, and they matched these two sub-expressions and just swapped this whole sub-expression, right? So that's why it is like that. So you have head and body, both of them are expressions, and you associate a name with two expressions, head and body. So that's basically how it works. You can keep applying it, right? So you can keep swapping around if you want. So it works. So that's how it works. That's how it works. So, all right. This is my bell. So how we're going to be applying everything? So the application looks the following way. First, you have a keyword called apply, right? Then the name of a strategy of the rule application, right? Bell, yes. It's actually a lamp. It's not a bell. Anyway, so you have a keyword apply. What if you swap A, B plus C? That's a good question. Here's the interesting thing. If you do A plus B plus C, it will be parsed like this, because that's how the parser works. If you try to do shape, it will actually demonstrate you that it looks like this. Right, and if I try to apply the rule swap to the first match, it will swap these two things, because that's the first match. Right, as you can see, it swapped A and BC. But at any point you can say, okay, apply that to the second match. And as you can see, it swapped them in here. So you can choose what sub-expression you want to apply this rule to. And that's one of the things that I always want you to have in Coq, right? Maybe there is something like that in Coq, but in Coq, you have a theorem, right? A proven theorem, but you want to apply it to like a very specific case somewhere in the sub-expression, and it's really, really annoying to do that for some reason, right? I always want you to have a language where you can say, okay, enumerate all of the matches, right? So just number all of the matches. The first one is going to be 0, then 2, 3, 4, and so on and so forth. And let me just pick where I want to apply that transformation. So, and this is what I did in here, right? So I have a rule, and I can literally pick where I'm going to apply the transformation. It's so convenient, isn't it? I think it's pretty convenient. So, yeah. Okay. So apply indicates that you want to apply a certain rule, and the second argument of apply, is the strategy, right? And the strategy is basically like to which sub-expression you want to apply, right? 0th one. Or we have a special strategy called all, right? So it will basically traverse the entire AST, and every time it encounters the match, it will apply the rule to the match, right? So you can just apply to everything. We also have a deep strategy that actually goes deeper into the sub-expressions after it transformed them. So it's a very interesting thing. So using that, I implemented the inverting binary tree. So you can encode binary tree with an expression. Then you can define a rule, right, which matches the value left and right subtree and just swaps right and left subtree. And you apply this rule with the deep strategy. So what it will do, it will apply the rule to the first match and then go deeper into the resulting sub-expression, like basically inverting the tree, right? So, and I can even demonstrate you, hopefully. So I can do something like that. Example, invert binary tree, and this was the initial one. And after that, it actually swapped. So as you can see, left was 1 and right was 4. And now left is 4 and right is 1. Here 5 was left and 6 was right. Now 6 is left and 5 is right. So as you can see, it actually traversed the entire tree and just inverted the whole binary tree with the deep strategy, right? Every time it finds the match, it replaces it, but it also goes deeper, deeper and deeper. So, yes. Basically, what I'm trying to do, I'm trying to make an approachable Coq. Feel free to clip that out of the context. So, so apply deep 4. No. The problem with 4 is that when you apply 4 is not applicable anymore. the next rule that is applicable is 3. So I'm gonna show you rel wrap. I'm gonna load std knock, right? So I'm gonna start shaping 4, then I'm gonna apply apply rule 4. But the second time it is not applicable anymore because there is no 4 in there. The next thing you have to do, you have to apply 3. Then you have to apply 2, then you have to apply 1, then you expanded everything. So essentially, we need some sort of a mechanism that allows to combine rules with assign or. So you need some sort of like a rule combination of like that rule, or that if that rule didn't work, use that rule, or that rule, or that rule. Maybe we're gonna have rules with several heads and several bodies that are applied sequentially, and the first one that matches will be applied, or something like that. I haven't decided yet. So the problem with the rules with several match statements is that it's unclear how to reverse them, because right now, like I applied 1, right? I applied 1, but at any point I can reverse 1 and it will turn s of 0 into 1. Then I can reverse 2, then reverse 3, and reverse 4, and just basically apply it back. So if I have a rule with several match clause, how do I reverse it? Because they may end up in having like the same patterns or something like that. It's really unclear, especially if you have something like rule. All right, so rule end. So A gets turned into, let's put it this way, A turns into B and C turns into B. If you revert these two things, you get a rule with 2 B's, and which one do you pick in here, right? So it makes really no sense. So I'm still thinking how we're gonna be doing all of that, but yeah, anyway. So it's not really that important. I'll come up with something. And once we have the rules that can be combined with assign or, we can have like a thing that automatically expands numbers, right? So we have number 5, it will automatically apply the rule that combines the rules for all of the numbers, right? And just expands it accordingly and then apply the arithmetic transformations and whatnot. What would language like this be useful for? It will be useful for me, because quite often I like to doodle around with mathematical and algebraic expressions and prove like a very simple school math theorems. And again, it's difficult for me because I make a lot of mistakes, but now I have a program that can help me to do that. So I'm primarily doing this program for myself. So I'm primarily making that program for myself. Okay, so yes, sir. Okay, so when we start the shaping, right, we do the application. And again, so the theme of the syntax reformation, so to speak, is that taking these keywords and turning them into binary operators. So what I'm thinking is that, so this one has to be all. What if we get rid of apply keyword, right? And replace it with something like some sort of a separator, right? So we're gonna start with the strategy, right? And then we're gonna separate the strategy and the actual rule, right? So let's actually put some sort of a bar in here. And if you put bar, it actually creates a very cool syntactical thing, right? Something like this, where I can just select everything in here and align like this. So there we go. As you can see, this is the process of shaping, and within the process of shaping, I'm starting with like what, you know, the index of the sub-expression that I want to apply things to, and then the actual rule. So the thing that you see in here is basically an anonymous rule, the rule that doesn't have any name. Right, so it's sort of like an intermediate rule that I don't really want to like extract to anything. I just want to quickly apply it, and I do have a syntax for that, right? So quickly apply this rule, but don't give it a name, just forget about it after you applied it. Pretty convenient. So since I'm trying to get rid of the rule keyword, so what I was thinking is that maybe the anonymous rule with the new syntax is basically gonna look like this. right? So the rule definition is essentially the name of the rule, colon, colon, and then the definition of the rule, head equals body. Right, if I have an anonymous rule, it doesn't have a name, I can literally just say, okay, it doesn't have a name, but it's a rule, so it has colon, colon, and here is the definition. So it's anonymous rule. So here I'm applying like quick intermediate rule to the first match of that specific rule. Right, so, and this entire thing may start looking like this. Interestingly enough, this allows me to have several strategies in here, right? So I can say something, okay, apply this rule to first match, maybe this match, and also this match. Why not? So that would be actually kind of cool. That way I don't have to repeat myself. If I have to apply it like several times to different parts of the sub-expression, I can just like list different strategies. I can simply list different strategies and just say it in here. To use dot dot instead of all. I don't know, I can also use star. Also makes sense as all. Triple dot. I don't know, you can use all the things. But on top of all, we also have deep, which is also unclear how to denote, but in any case. So what do you guys think about this sort of, you know, syntax for the language? And to make it even more like, you know, C-like or Rust-like, we can replace the keyword load with use. Right? And this is how the language looks like. The semantic of the language didn't change, but it started to look more modern. It doesn't look like a granny language anymore, right? So, and this is all about look and feel of the language. So if I take a look at this entire thing, so this is how the language looked like, and this is how it will look like, right? So this is the rule definition, this is how I do shaping and whatnot, and yeah, there we go. Double dot for all and triple dot for deep, maybe. Wouldn't putting the name of the rule before index be more C-like? But here's the interesting thing. The rule that you apply may not necessarily be a name. Right. It could be like an actual rule. So I could probably like swap them around. Okay, so this is going to be the rule, and then this is going to be the index. But what do I do in this case? Do I also swap it? But it could be actually indefinitely large. It could be indefinitely large and it's, I don't know. So it kind of makes sense for me to actually keep these strategies like on the left, right? And you can actually like decide what kind of strategies you can have. The only problem I see in here is that sometimes I want to reverse the rule application, right? So I have a particular rule and now I want to reverse it and treat its body as its head and its head as the body, right? Reverse the application. And for that I use the keyword, which is still like gives an additional keyword. It's a long keyword, it doesn't really look great. So what I'm thinking is that maybe we're gonna go a different route, right? So we can treat each strategy in a strategy list as a separate application of that rule, right? Each strategy in here is separate application of that rule, and basically I'm applying dir def rule 3 times in here, right? So I basically collapsed 3 different rules in here into one. So, and if I want to reverse a specific application of the rule, I can do that on the level of the specific strategy name. So for the application number 1, I can say, okay, apply that, but apply it in reverse. You see what I mean? What if we change the rules that apply to the same index? So here's the interesting thing. I'm trying to change the syntax that will not require changing the semantic too much. So if we're chaining things together, it actually starts to overlap with the semantic change too much, right? And right now I'm not really eager to change things semantically, if you know what I mean, right? So for now, I just want to like preserve the semantic as much as I can. Of course, there will be some semantical changes because of this stuff, but I don't want to do too much. You could place, yeah, probably, maybe I'm gonna put it in here, right? Who knows? So, but I really like that you can basically align this as a single line, right? You align this as a single line and just like that. At any point, if I can just basically quickly realign. Yeah, that was kind of weird, but okay. Right, and it looks like a table. Or just before the rule. Again, people who are suggesting before the name, how do we treat the inline rules? Right, or inline rules are not reversible. So what if I want to do an inline rule, right, and I put this thing in here? But at the same time, you can argue if you're doing an inline rule, if you need to reverse it, well, you can just like type it like you reversed it. But counter argument to that would be, what if the inline rule that I wrote is too huge and I'm too lazy to actually revert it? That's a good point, actually. Though, and another interesting thing here is to use this as an indication that you're reversing, which is actually super close to the original semantic. Right, because before we just had a reverse keyword, and what we essentially did, we replaced the reverse keyword with exclamation mark, and it stayed the same. Right. So I think I'm gonna actually use that. I think it's a good idea. Thank you. It's just, and on the level of tokenization, I'm gonna just actually treat this as a separate token. So yeah, I think it's a good idea. Thank you so much. It's not a bad idea. It's not bad at all. But applying it on the left is also a very intriguing idea. But applying it on the left is also a very intriguing idea. I guess we'll see. But I'm gonna go with this idea because it will require the least amount of changes, right? Because we already have that semantical structure, right? It's just like instead of exclamation mark, we're using keyword reverse. So it will be super easy to add that syntactically. And furthermore, we don't even have the strategy list right now, right? So there's no like even semantical basis for several things in here. So yeah, I think I'm gonna go with this and we'll see how it will evolve, right? So this is the syntax bike shading everyone was waiting for, am I right? Right, because I always avoid this topic, right? Because I focus on the functionality of the language. The functionality of this language is pretty much done, right? So I don't think I'm gonna make like a very big changes in terms of like semantic of the language. This is the language I wanted. So we'll see. It would be kind of cool to integrate with language with some sort of like tools that make it comfortable to work with, like something like Jupyter notebooks. You know what I'm talking about? It would be really cool if this was if there was an integration with the Jupyter notebook. You know what I'm talking about? Right, so this is a notebook style language. LaTeX rendering. I'll think about LaTeX actually. It's not a bad idea actually to have a LaTeX rendering. So take the, you know, some sort of a theorem proof and generate like a PDF out of that with the proof and stuff like that. That's a cool. I'll think about that. That's a very interesting idea, chat. Chat is generating cool ideas. Okay, good. Alrighty. So, but let's go back to original syntax. So I actually want to start doing this kind of stuff incrementally. So this is how the language I want to look at. This is how I want the language to look like. And this is how the language looks like right now. So, well, I mean, at least it has a syntax highlighting, but that's the look and feel of the language. And related, what's O of n and O log n roles on server? Oh, you mean on Discord? Yeah. Yeah, on Discord server we have roles that look like asymptotics, right? O of n, O log n, I think the first one is n squared, right? So there's n squared, then linear, and then logarithmic. So basically, these are different Twitch tier subs. So the square is the tier 1, linear one is the tier 2, and logarithmic one is a... Actually, I'm not quite sure. I think I think it's more of like a linear, logarithmic, and constant. So the better asymptotic, the higher the tier of sub, right? So that's basically what it is. It doesn't really give you additional perks specifically on Discord, but it is what it is. And serverless NOC hosting soon, yeah. So will the verbose keywords be completely removed or kept as aliases? Here's the thing. Verbose keywords require a different position on the like syntactical position completely, and a different way of parsing, so I think I'm going to be removing them. Alright, so first of all, we need to tokenize things properly. In a language I recently implemented parser and Lexa debugger, right? So you can provide debug, special debug flag, right? And then you can say, okay, I want to test the parser, right? And as you can see here is the parser, and you can provide an expression, right? Just any expression, and it will parse it and will basically describe how it parsed it. So this is how it will display your parsed expression. Then it shows the AST, and if there is something that was unparsed in the Lexa, it's gonna go here, right? As far as I know, you can create such situation if you, I don't know, do something like this. I don't remember, but there is a situation when the expression ends and there is something unparsed in here. So, and also you can test the Lexa, right? So you can test the Lexa, you can just provide some stuff in here, and as you can see, it turns it into a sequence of tokens. Unfortunately, like, it's a little bit, you know, inconvenient. For instance, if you have A plus B, right, it will treat A as identifier, plus as plus, it recognizes it as a separate thing, then B as identifier, and then at the end of the Lexa, like token stream, there's always end, right? There's always end. So we also support strings, for instance. You can do something like hello world, right? And as you can see, so string is a separate token, and stuff like that. So you can test how things are tokenized. Does end contain 0? It depends on what Rust string contains. I don't think it matters that much. So anyway, now we need to see how like colon is tokenized, or whether it's tokenized at all. I doubt that it's tokenized at all. I think it will throw an invalid token. Right. Oh, okay, so this one is interesting. So we have a colon. Wait, what do we use colon for? Do we use colon for anything? I don't remember. Damn. Huh. I don't remember using colon for anything, but apparently our parser, our Lexa, excuse me, our Lexa recognizes the colon, which is rather interesting. Didn't expect that. So just a second, I need to do something like this. All right. So let's try to make it recognize colon as a separate token, right? So let's go to the Lexa module, right? So we're gonna have a Lexa module, and let's find the keywords. So we have a colon, and I don't remember if we used colon for anything. I think colon is just there because I was kind of planning to have a different syntax, and I just like put it there, but okay. So let's do colon, right? So now, as you can see in the token kinds, we have colon. So let me know, cargo, build everything, and let me see, colon clone, okay. Colon, all right. So, and in here, colon. So this is a colon, double colon, maybe? maybe we should call it double colon. Query replace colon colon double colon. Boom, 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 boom. So what else do we have in here? So this thing is unused. All right. All right, all right, all right. So how are we going to be doing all that? So look, we like clean everything up before like taking some token. We basically strip all of the white spaces, also comments and whatnot, and then we look at the first, that is the first character that is not space, and we look at it. What is it? Open parent, close parent, and so on and so forth, and we see colon. And right now when we see colon, we recognize it as a separate thing, and we just like return such token. So another thing that we have to do, right, I think, is to pick into the next token, right? So that's what we need to do. And if the next token is also colon, we have to group it into a separate token as well, into double colon, right? So let me see. We have, if I'm not mistaken, we have the iterator of characters, right? So, and it's a pickable iterator, meaning that it has a next if. Right, it's a method that accepts a function, right, that acts like a predicate. It gives you a character, and if that predicate is true, right, if that predicate is true, it will remove that element from the iterator. If it's false, it's gonna keep that element there. That way we can do the following thing. If the next character is also colon, we're going to return the kind token kind double colon, right, and with the corresponding text and with the corresponding location. But here's the interesting thing: text right now contains only colon, right? So it contains only colon. So I also need to add another colon in here. So text is the actual sequence of characters of the token. So there is a class of the token, kind of the token, which classifies the sequence of characters, and also there is the sequence of characters. Right? So to maintain the correct sequence of characters, I need to add additional colon in here and then return the token. So otherwise, right, if this predicate was false, that character is not going to be removed from the iterator, so I can return these tokens. So we still recognize single colons and double colons, right? So single colons and double colons, and I would say that's pretty much it. We can probably remove these things, right? So we can do something like this, and maybe even something like this. Boom, look at that. So double colon, this has to be a double colon. Oh boy, so let's try to compile that. So it's gonna be just built and see if we're gonna have some stuff. All right, so let's restart the parser and let's try to do something like this. As you can see, it's a double colon B, but as I already said, we also distinguish a single colon. So there is a single colon, there is a double colon, and if you put triple colon, I suppose it will be tokenized as double colon plus single colon, because first we parse the, we sort of a little bit greedy, right? We're a bit greedy. If we see the double colon, we automatically parse it as a double colon. So this one is going to be double colon plus colon, and if you do another one, it's a double colon, right? So there's two double colons in here. So everything is more or less tokenized as I would expect. Is white space around mandatory? No, it is not. So as you can see, it's going to be like this. It is not mandatory. So, and that's actually the responsibility of the Lexa or tokenizer. By Lexa and tokenizer, in this context, I mean the same thing, right? So Lexa and tokenizer is just basically synonyms. And to make these spaces not mandatory is the responsibility of the Lexa. That's pretty much the whole purpose of the Lexa, pretty much. Plus also classifying the sequence of characters. So, yes, isn't it cool? Isn't it cool? I think it's pretty cool. So we distinguish double colon, and now we can even use that for parsing rules. That's what makes it very, very interesting. So maybe the next thing I'm going to do, I'm going to try to remove rule, right? I'm going to try to remove rule, and that will essentially break the code in all of the places where I have to go and change the way we parse things. And that way, I think I will change the syntax of the language, I think. Not 100% sure, but we'll see. So I'm going to try to remove it, but maybe before I do that, I'm going to commit whatever I have so I don't lose any information. So it was actually rather easy to add, right? Relatively easy to add. Okay. Add double colon token to Lexa. Let's push that right into the repo. You can find the source code of the repo in the description or in here in the chat if you're watching on YouTube, right? Okay, guys, so let's go ahead and remove the rule, right? So, and see in what places the application fails, right? So what do we have in here? So we don't have a rule anymore. I'm gonna remove that. Okay. So what is that? We're parsing something, we're parsing self, we're parsing applied rule. This one is really, really interesting because applied rule is the argument of apply, right? So if I take a look at the example, right? So there is a rule definition, just defining a rule, and there is a rule as an argument of the operator apply, so to speak. You see what I mean? So whether it's a name or anonymous rule, right? Applied rule is this thing. Right, it's either a name or inline one. So that's basically what applied rule is. There's a rule definition and the rule that you actually apply during the shaping, right? So this is where it failed. It failed in the place where it was trying to parse an anonymous rule, right? So you see it looks for a token rule, right, and then it just constructs an anonymous thing. Luckily, with our new syntax, it is basically equivalent, right? So it's gonna look like this, right? So essentially, we're replacing the keyword rule with the keyword double colon, right? It's not really keyword, but it's just like a double colon. Make desugaring step that replaces rules with inline rules, so in end everything is inline rule. Why? It sounds like more work, actually. Right? I need to add an extra step. Like, it's already more work than whatever I have right now. So adding extra step is is not gonna make less work, it will make more work. So I didn't think it's a good idea, sorry. Okay, here's another place. So we are parsing command. Okay, command is a very interesting thing, right? Command is a single line within REPL, right? It's a single line within REPL, and essentially it's a single line in here. So a single line here is a define rule, or start shaping, or apply rule, right? So one of the commands we have is define rule, and this is where, right? This is where we're starting to do this kind of stuff. Right, the way we parse commands is rather interesting. It's because we basically take the next token without looking ahead, and based on that keyword we decide what command we're parsing, right? So we saw load, that means we're loading file. We saw rule, that means we're defining a rule. We saw shape, that means we're starting shape. We see apply, that means we're applying. Done, undo, quit, delete. Oh, we have a delete, by the way. In REPL you can define a rule, and then if you want to redefine it, you can delete it. Right, so we have a special command for that as well. I didn't demonstrate it, but you can delete an existing rule if you want to. Alright, Epicu, isn't it Epicu? I think it's pretty Epicu. So I think we need to change it slightly. I need to look into the next token, essentially, right? So I think this one has to be pick, right? This one becomes pick. And if it's load or any of the other existing rules, we have to sort of materialize it, right? So we have to do Lexa next token. So though when I do peek, does it return just a pointer? I don't quite remember. So peek token, it returns the pointer. I mean, it's a reference, right? In Rust we call them references, but actually they're pointers. Right, or reference, oh, doesn't matter. It's just a name. It's just a name. So this is just that. But what's funny is that I think we need to take that stuff and take its kind. So I cannot just match this thing so easily, because essentially what we do, we're borrowing the whole Lexa, right? We're borrowing the whole Lexa. So I need some way to like not borrow the entire thing. And the only thing I want to do, I want to pick into the kind. So maybe I'm going to actually have keyword kind in here. So, and that way I can like, you know, pattern match like this. Once I see that it's a load, I can just remove that token and then, you know, parse everything else. In terms of rule is going to be rather interesting. So I think I'm going to just do something like this. I'm going to move it in here. In case of a shape, that's another one in here that I'll have to do. So this is going to be next token, and apply is also next token, and also for all of these things as well, right? So we got another sub, Pulpy Code. Thank you so much for Twitch Prime. If I missed any subs, I really apologize for that, because sometimes I may miss them, but thank you, I really appreciate them anyway. Alrighty, so let me see. So this is going to be something like this and something like this. Okay. So there we go. Cool. So probably should remove that stuff. Nice. So, but if we didn't encounter any of these things, we should try to parse a symbol, right? We should try to parse a symbol. And this one is going to be rather interesting. So I'm going to take this entire rule. So the syntax, as you can see, becomes a little bit more complicated, right? It's not just like look at the next keyword, and if that's a specific keyword, just, you know, dispatch to something else. No. It's not going to be like that anymore. So yeah, we're trying to expect the next thing to be identifier, right? So, and then after the identifier, we expect something else, right? So this is identifier. That's cool. So maybe we're gonna call it a name. And after that, I literally expect token kind to be token kind double colon. Right, so this must be double colon. Otherwise, it's going to be something else. And I think that is pretty much it. If you don't have any keyword and you just start with the identifier, it must be, at least right now, later is going to be different, but at least right now, it must be a rule. What's up, Drots420? Your voice is so soothing, and this is because I'm not pissed off. Right, so usually when I'm pissed off, my voice is not that soothing. Cheers. All right. Okay, let's take a look at all of these things. So here is the keyword, like, okay, this one is cool, right? Because we're starting to use like different locations and whatnot, right? So that means I can actually do something like this. So this is going to be the keyword. Okay, so essentially we need to grab those keywords in here. Anything else? I think that is basically it. Anything else here? Keyword. Oh boy, this one is rather interesting. So we're using keyword location as the location of the rule definition. Right, it's a location of the rule definition. I think we have to use the name location. And we're using it like that. Are you handling multiple keywords cases? What is a multiple keywords case? I don't quite understand. What is that case? I never heard about such case. Consider removing the semicolon. I don't see a semicolon. Okay, so I can see the semicolon. All right, we have shit ton of warnings. Let me see. So there's no rule anymore. That's cool. Okay. Keyword. This one is not used, so that means I just have to do something like this. What language I'm building in here? I'm building a language called Nock. It's a language for like basically transforming algebraic expressions, and for anyone who's watching on YouTube, you can find it in the description. So yeah, so the language is almost like Coq, but it's actually not Coq, right? Like this one. Expected command. So this thing is never used, right? Which I guess makes sense. So for now, I think we can remove that ever, right? And we don't really have to handle it anymore. Coq, it's the French research project, yes. It's created by the same people who created the camel, yeah. So I think, I'm not sure if the same people, but it's the same university, at least, right? So, and they used a camel to code Coq. At least that's what I know about it. All right. And essentially, what kind of language am I creating, right? It's a language where I can define different rules, right? So I can start defining, for example, sum commutativity, right? So in sum commutativity is when a plus b equal b plus a, right? So, and I just defined a rule called sum commutativity. And then we can consider some sort of a sum, right? F of x plus g of y, right? And then I can start a process that is called shaping. Process of shaping is the process of applying a sequence of rules on some sort of expression, right? So I'm starting to shape this thing, and then I can say apply sum commutativity on the match. So you can actually match that rule on different sub-expressions, but use the match with the index 0, right? So, and they're numbered in order of DFS, right? So we traverse an AST in DFS, and as soon as you encounter a match, it's called 0, 1, 2, 3, and so on and so forth. I apply some commutativity, and as you can see, it swapped f of x and g of y. Right, and you can define arbitrary amount of different rules that match different sub-expressions and then apply them sequentially, sort of demonstrating a proof. Not really proving anything, but you mechanically demonstrating some sort of a proving process. So that's the point of the language. Right, so my problem with Coq is that it's too formal, it's too rigorous, it's too mathy. And it's mathy in a bad way, in a cryptic way. You know how mathematicians are like basically turn into this like information bubble, like elite subculture that doesn't let anyone in. So Coq is bad in that way, right? Unfortunately. So, and what I'm making, I'm just making like a very simple mechanical expression substitution thingy. And thank you, by the way, so much for tier 1 subscription, for 6 months of tier 1 subscription. View matches command to so we're gonna implement some mechanisms to actually see like indices of the sub matches and stuff like that. Right, so and you already can do a lot of different things, right? So we have a standard library where we have, you know, defined some things, right? We defined some laws in here, some axioms, and you can even, like, you know, sort of prove some theorems and use them as rules. What we're doing right now, we're just like changing the syntax of this entire thing, right? So we're changing the syntax. So instead of like defining rules like this, I'm pretty sure you now have to define them like this, which in fact looks way better in my opinion, right? So you give the name of the rule and then separate the name from the definition, and definition is a head equals body. Pretty cool, I think. So let's actually go back and see how the entire thing is going to break. So I'm going to do cargo run std std.knock, and it will fail in here. So as you can see, it says expected double colon but got identifier 1, which is in fact the case, right? It is in fact the case. So what we need to do, because basically it treated rule as an identifier because it's not a keyword anymore. We removed it from the list of keywords, right? It's not a keyword anymore. So let's remove this entire thing and just do it like that. Cool. It defined rules 1, 2, 3, 4, but then it failed in here. So basically what we have to do that for all the rules. So let's quickly do that. So this one is going to be something like this. Yep. We're going to use a little bit of an Emacs magic to actually make that happen. It's starting to look like Jai. Yeah, I think in Jai it is a thing where you have a name, then this, then the arguments. I think it is a Jai thing. I just realized that. Never thought about it. But no, we can do something like that. We can align everything like so. About that. The Odin, it's the same as an Odin. Odin is the we have a Jai at home language. I'm sorry. I'm joking. So yeah. Okay, so this is what we have. And here is the interesting thing. Right. So will it just work? Well, we'll see. The winner gets 2, that's for sure. Okay. Expected double. I think it will work. If I remember correctly how the parser works, I think this will just work. Yeah, it actually did just work. Cool. Alright, so yeah, I just changed the syntax. So now you can define the rules like this. Right. So the shaping is still granny style syntax, but definition of rules is actually like way better. So let's take a look at some of the examples in here. So dear square. So this example is really cool, right? Because it basically demonstrates the derivative of a square, right? So let's actually try to run. Dear square knock, and it fails right in here, right? So we're gonna do it like that, and then like this. So and probably in other places, right? So this one is gonna be something like this, and another one like this. Cool. So as you can see, we have function square, right? And it's a derivative of square. Through a sequence of transformations, we demonstrate that derivative of square is equal to 2x. What are the use cases for this specific language? Who actually codes something with them? The use cases is when you need to mechanically transform the algebraic symbolic expressions. Who uses this language? I use this language. And it's a genuine answer. Right, I already explained that several times. Right, so sometimes I just doodle around with mathematical expressions and proven, school algebra theorems and stuff like that for recreational purposes, purely for recreational purposes. Yes, I am weird like that, I'm sorry. So it is my recreational activity to prove that, sum of squares is equal to, a squared plus blah, blah, blah. And also, I do this kind of shit with pen and paper occasionally recreationally, right? But since it's a very intensive, like requiring focus process, I make a lot of mistakes. It's super easy to make a lot of mistakes while you're mechanically transforming the expressions. And I decided, why can't I just tell the computer to do that? Right. So, and thus I created Knock, so I didn't have to do that manually anymore. So this is the use case, and who's the user? User is me. So does that answer the question, right? For some reason, people like don't believe that that is actually the use case, but it is literally the use case. There is no other reason I created this language for. Literally no other reason. So, and it's open source. If you find it useful, right? So if you find it useful for whatever reason, feel free to use it. Okay. So, that's very cool. So now you define rules with double colon, right? So that's how we do that. The only thing you're allowed to do with software is write for an enterprise app. No fun here. Yeah, exactly. All right. So let me do a committee and maybe even a push. Though I need to actually check all of the examples, right? So we have that. So the next one is going to be dir sum. Yeah, this one is also cool. So let me go here. Okay, and this is also another thing. Is it gonna work? Right. So this one is really cool. I have function sum. Sum of x is basically f of x plus g of x. It's sum of two functions, right? That's what it is. And I basically try to find what is the derivative of sum, right? And the derivative of sum, as you can see, after a series of expansions, is the sum of derivatives of those functions, right? So, and I just mechanically apply pre-existing rules, except for maybe like redistribution of parentheses in this specific case, because I didn't really have like anything that fits in here. So I decided, whatever, I'm gonna just like regroup things like that. And this is what I like about it compared to Coq. In Coq, everything has to be formal, strict, you have to prove anything. It's really difficult to just doodle around, right? If I want to just check something super quick and I like stumbled upon some problem and I realized, I have to prove that as well. Okay, just replace these two sub-expressions like that and let's just move on, right? So you can quickly do that. And because of that, it doesn't replace the Coq, right? It doesn't replace it, right? It's just like, you know, sort of an additional tool. I think you may consider it an additional tool in your tool belt if you're ever gonna put it there, because like I'm not sure if anyone will find it useful except me. Do you have a background in programming language development? Formal? I don't really have a formal background in programming language development. Or did you learn PL Dev to make this link? No, I never actually. I mean, I learned programming language development accidentally. Essentially, I was just programming, just doing different kind of programming and stitching the pieces, the pieces of knowledge on how to create programming languages together, like over the years of just programming. If you know what I mean. It's just like, yeah. I don't know. I treat it as any programming problem, right? So I consider myself just a programmer. Right, so I have a problem in front of me. I need to develop a language, and I approach the problem as a programmer. And everything I learned through just solving the problem of creating a language. Does that make any sense? I don't know how to explain that, but I never read a single book about making programming language. I just learned that by creating a language. Does that make sense? I'm not sure. Right. So essentially, I rediscovered a lot of things. Yeah, I don't know. Maybe. What's interesting is that a lot of concepts in programming language development are rediscoverable, right? Because once you start trying to parse the language, you quite quickly realized that you need some sort of a pre-processing step that first groups important sequence of characters into these bundles, and then you analyze the bundles of these characters rather than the individual characters themselves. You really quickly actually learn that yourself without reading anything. And in all of the literature, this process is called tokenization or lexical analysis. It is easily discoverable if you just try to do it as a programmer, right? You have a problem, you need to, you have source code, you need to build a tree out of the source code. You start doing that and you realize that you need this pre-processing step. And you then discover that this pre-processing step in the industry is called lexing. So that's what it is. So that's how I learn usually this kind of stuff. I know. I just try to do things. Off-topic question, what is your opinion will prevent Rust to be as hated in 25 years as C++ is hated now? I am a programmer. I'm creating software using programming. Hatred towards a particular language is not a part of a programming, thus it's outside of the scope of what I do. So it's a very much off-topic question because it has nothing to do with programming. It's not only off-topic in the sense of today's topic of the stream, it's off-topic in the sense of it's not about programming. So you read some literature after you found stuff. Yeah, of course, right? Because then once you discover something, right? Once I discover something, I start Google things about that thing, and I discover the name of that thing, right? So and then I read more, and since I already discovered some of that knowledge, the discovered knowledge kind of helps me to acquire new knowledge that other people discovered. So it's sort of like a self-perpetuating process. So it's not like I discover everything myself. I discover myself a little bit that helps me to actually learn things. You see what I mean? Right. I try to solve problem. I discover something, and I start Google things about that, and I discover even more things that other people discovered, and then I just stitch the knowledge together into coherent picture. Right. Okay, that's my approach. If it will work for anyone else, I don't know if it will work for anyone else, but it works for me. Okay. Alright. So what do we have? So I need to go to other places, right? So here is the sum. Invert binary, we also have to do that. I'm gonna go and invert the binary tree. So yeah, the same thing. And piano numbers. Oh, here I just prove, like demonstrates the operations of different things, like 2 plus 3. And I didn't even have 5. How does that even work? Probably doesn't, right? Because I do not reverse it back, so it's just like whatever. Okay, so I'm gonna run it like this, and it just worked. Oh, surprising. Piano. Right, so that looks all right. Cool. So maybe I also need to change the thing in the readme, right? Because now rule is defined like that. Though I don't really have that much information in the, in the description, in the readme, unfortunately. Should probably expand. Maybe I should write like a So I'm not sure if I'm gonna keep it like this. Maybe I should start writing like a manual, like a reference of the language in here, describing it. But the language is constantly changing, so it's kind of difficult to describe it. Update the rule definition syntax. Right, so the rule definition syntax. I'm gonna push that right into the repo. So, alrighty. So let me see. So the next change that I want to make, as we already discussed, is how we start the shaping process, right? So instead of starting the shaping process with a special keyword, right, we're gonna start it with just an expression that you want to shape, and then opening a curly brace, and then you finish the shaping process with closing the curly brace. So that's how we're gonna do that, right? So, and that will transform into something like this. So I think I'm gonna do that in the standard library, because we do have this kind of stuff in the standard library. Right, so I'm gonna start it like that, and there you go. Though there is like two different like ways to start the shaping. The first one is without rule, and then with the rule, and they are parsed differently. Dirty Forest Rat, thank you so much for tier 1 subscription. Thank you, thank you, thank you. Okay. So I need an example where we do not define a new rule, and it's probably going to be somewhere here. Yeah, let's actually go ahead and do that. Anyway, so I'll need to extend the Lexa, right? I'll need to add open curly, right? And then close curly, right? So it's going to be open curly and close curly. So open parent, right? Open curly. I'm gonna write like this. Open curly, and then close curly. There we go. Close curly. So we have everything in here, except we do not really parse them. So if I try to now debug the Lexa, right? So I'm going to be debugging the Lexa. I'm going to have something like this: A, B, and as you can see, it says that this is an invalid token, and then it stops after invalid token. All right. Now I need to just find this thing. So this one is going to be something like that. RL wrap thingy, it's actually very cool. So essentially, if you heard about read line is when you have a history, right? So in a bash, you have a history, you can go up and down, you can search and stuff like that. This is provided by the library called read line, right? But some of the applications do not support read line stuff. So you can have a RL wrapper that takes your program without readline support and turns it into a program with readline support. So you can find this thing in here if you're interested. So let me see. So description, RL wrap. It's pretty cool. I really recommend it. Okay. So now this one is going to be token kind open curly. Open curly text lock, and then something like this. This one is going to be close curly, right? So this is a close curly. So if I try to debug the Lexa afterwards, right? Debug the Lexa. A plus B like this, and this is not debugging Lexa, right? Debug Lexa A plus B. Right, okay, so it actually recognizes them, so we have open curly and then close curly, right? So that's pretty cool. That's pretty cool. Okay, so the next thing we need to do, we need to somehow parse that. So there is a problem. You define a rule by starting with the identifier and then double colon, right? So this is your rule. Then you start shaping. Right, you start shaping by doing something like this, right? So you provide some sort of a pattern, and then you open this thing, right? You open this thing. So and in here we have only identifier, only a symbol, right? It is identifier in the terms of lexing, but here we have a whole expression, right? So what we have to do, we have to parse the entire, both of the things as expression, and then look at the next token. If the next token is double colon, we have to check if the previous expression that was parsed is a symbol, and if it's a symbol, we can define it. If it's not, we have to throw an error. And if it's open curly, we have to treat it as starting the shaping process, right? So we preemptively parse the expression, and then we treat it as a different command depending on the next token afterwards. So this is how I think we're gonna distinguish between them, between the rule definition and starting shaping, right? Does that make sense? I think it does in fact make sense. So it will require additional check that the parsed expression is a symbol in case of the next token being double colon, but that's fine, I suppose. So although we can actually do a little bit, like it requires more look ahead. If we want to do that properly, we need a look ahead on like 2 characters ahead. So, but we don't have that. We can only look ahead by 1 token. So yeah, that's the approach we're gonna take. We're gonna preemptively try to parse an expression and then see what's the next token. So, and to actually start the whole process, I think I need to remove the shape keyword, right? So that will, you know, break everything. All right, so, okay. So we don't have a shape, and here is another one. All right, so this one is cool. Start shaping, start shaping. Let me move that thing. So this is a command. We're parsing the command. Okay. So here we are parsing the name. Cool. So I suppose here we can do something like expression, right? And I try to parse an expression. So this is an expression. Then I need to pick into the next token, right? So Lexa pick token, and I expect that token to be token kind. I can probably match that thing, right? So I'm gonna match that token. Then token kind. So we can expect either open curly, right? So this is going to be open curly. Then double colon. In case of a double colon, right? In case of a double colon, this one is going to be really interesting. We need to see if the expression is a symbol. That's quite important. So we'll have to match expression. If it is a symbol, it's going to become the name that is going to be used by the rest of the stuff. Though it's going to be very much unclear where we're going to take the location from, right? Because the symbol usually doesn't store its location, but in any case, I can just take everything in here and just put that under this thing, right? So I'm just putting that under this thing. So this is a symbol. And if it's something else, right, report that we expected a symbol, right? So this is what we have to do. Are you in Russia? Yes, I am in Russia right now, unfortunately. I wish I wasn't here, but I am right now here. It is what it is. It's gonna be okay, don't worry about me. My only hope is that the Putin's regime is dying, so I hope it's gonna die soon. and all that will be over. I got out of Iran, I feel your pain. Yeah, I can see that. I hope you were safe now. What do you think about using multi-line comments in a single line instead of like a single line comments? I didn't really think about that much. Why don't you parse a shape by checking the parentheses? Because the pattern that you're parsing may not have parentheses. Sodium regime, don't I? Yeah, we'll see. My regime has died a long time ago. I'm not sure if it translates really well, but in Russian language we call a sleeping schedule a regime. Not sure if it translates well. Do we call sleeping schedule a regime in English as well? I don't quite know, but in Russian we do. So my regime, which is my sleeping schedule, has died a long time ago. So, yeah. So, and we use a single word like regime, and we mean sleeping schedule by that. So, all right. So here's what we have. If it's open curly, start the shaping process. So you're hoping for Putin's sleeping schedule today? Yeah, exactly. In my language, regime also means diet. Oh, interesting. No, I don't think in Russian we use regime as a diet. Though I can see somebody doing that, but it would just sound weird, but usually we don't, yeah. I think it comes from the regiment, yeah. Do you know Russian language? Yes, I do. I also started to understand Ukrainian language recently a little bit, because I was listening to Ukrainian news outlets. Right, to get the idea of what's going on from the Ukrainian side. So... It is not particularly difficult for a Russian to learn Ukrainian, because it's a Slavic language, so they're really close. Even though Ukrainian is closer to Polish rather than Russian, but still. Polish is also Slavic language. Can you access money from Twitch at the moment? Not right now, but maybe later. Maybe when everything is over, maybe I'll have something, but we'll see. Alright, so let's continue. So this is a double column. Let me try to compile this thing. Okay. Cannot, probably because it's an expression, right? So, and shape is not working anymore. So I think I could at least put something like this, because right now I'm trying to make it compilable. Right, so because of that I'm going to just make it like this. Though, if it is open curly, I can actually do it like that. Yeah, I think it's gonna work. I think this specific thing is going to work. So we picking into that, and if it's something else, okay. And there is another thing for starting a shaping in here. So I should have actually removed this entire thing. all right. Oh yeah, I see. So here is the double colon. Nick Takadze, thank you so much for Twitch Prime. Thank you, thank you, thank you. For the future, then. Yeah, thank you so much. We'll see. I hope. I'm trying to stay optimistic that everything is gonna be over. To be fair, like, I don't know, money is not that important. After what has happened in Ukraine, it's just like not really fucking important. I don't even care if after everything ends, I won't have any money from Twitch or Patreon anymore. Like, I really don't care. I just want this war to be over so people will stop dying. Such horrible deaths. So, like, doesn't really matter anymore. Money don't matter. So. There's way more important things. What I was doing. So we have another syntax. And that syntax is trying to define a rule, right? And then we're trying to parse an expression, and then after that we're looking what's next. Is it equals or is it this? And depending on whether it's equals or this, we're treating it differently, right? So this is actually pretty cool. So there's like several layers of that there. There's several layers of that. So here we expect identify, so this is going to be just a name, but I'll have to go a little deeper. Just got here through your YouTube channel. Do you still have streams on Haskell? No, I don't. I kind of got tired of Haskell. So I think the stuff about this war is not just that the people are dying. It's not just people dying, it's how they're dying. That's the most horrible thing. The death of a person is a horrible thing, yes, it is horrible. But you can die differently. And that is what unsettling. So if you think about it, like, what could be worse than a person dying? Well, you can go even worse. You can die differently. And that's what... I have no words to describe what the fuck has happened. Anyway. Anyway, so we have identified. We have an expression that can be treated differently. So if you encounter open curly, right, it's a start shaping. Cool. Then if it's a double colon, that means we're trying to define a rule, but while defining a rule, we can start another shaping, right? It's a start, it's a define rule while shaping. I even have a command for that. Right. We even have a comment for that. So people say that the stream has been weird. Like, we dropped a couple of frames, right? So actually 1,405 frames. Right, so that's how many frames we dropped. So maybe because of that. So that makes sense. Okay, so here is another expression, and that could be either ahead. Interestingly, it is ahead in both of the cases. It is actually ahead. in most of the cases. Okay, so here's the name, then it's a shape. Okay, so that means I have to put this thing in here. All right, so I think I finally started to focus on what the hell I'm doing. Right, then I pick into this stuff. Right, so token kind shape. Actually, it's not a really shape. It's open curly. Right, so if it's open curly, we do one thing. Right. So it can be something like this, and if it's open curly, we don't need to do that. We already have an expression, right? So that's fine. If it is equals, right? If it equals, we have to do another thing, right? So here we don't expect anything, we just parse the body and we declare that to be a rule definition, right? And that is basically it. So here we have to say to do a report expected equals or open curly, right? So that's basically what we have. Right, so we have head. So then it's open, blah blah blah, and this becomes head. So the expression, the previous expression that we parsed is either head or not. Okay, that makes sense. What else do we have in here? This one has to be something like this. What else do we have? So this is an expression, sure. What else do we have? It's a shape. Let's remove the shape. So open curly, double colon, symbol. Though we have to duplicate this thing in here, I suppose. Okay. Name, this is an intentional prefix with name, so name is not used for anything, which doesn't make any sense. So here we're trying to, yeah, we have to remove this entire thing, that's for sure. So I'll have to go through this entire logic at some point and see if it actually parses what I wanted to parse. Location. Location is hard. Alright, so location is absolutely hard, and I'm not sure how exactly we're gonna do the location. Right, because in both of the cases we just don't have that location. Right, because we don't have a location associated with a symbol. If we at least had a location here, we could extend expressions to have a location, but I'm not 100% sure, so it's a good idea. So, you know what I'm gonna do? I'm gonna do location, maybe a default. Get the location of the name properly. Right, so we're gonna have something like this. And yeah, so in here we're gonna have default, right, and the name is just gonna be that. The same goes here. Maybe I'm gonna also duplicate to-dos for here and for here. Do we have anything else? So what do we have? So the text does not exist. Okay. Is not implemented for Lex. That's really interesting. Why don't we have a default in here? So let's actually quickly implement. I think it should exist. All right. And okay. Cool. That's actually pretty cool. Expected. So that was not what I would expect. So we parse the expression. Then we pick into the next token. If the next token So we start shaping. I see what's going on. Alright, so we have to move the expression in here. Alright, so I suppose maybe that was the problem? Still not the problem, but okay. So here's the expression. Next one is open curly, right? Then we start the shaping, everything's fine. The next one is double colon, which means that after that we have to remove it because it was only picked. So that's quite important, in my opinion. So we have to do something like that. So that means Lexa next token. And this is where we can have the location that we always wanted, I think. Keyword, right. So that could be the location we always wanted. So I can just put keyword location in here, removing the to-do, then the keyword location in here, removing the to-do, and also keyword location. We'll see how it goes. Maybe it's gonna be fine. Sure. Okay, so then I take the token, I remember its location, that's fine. And I then take that expression, right, and I try to see, is that a symbol? If it's not a symbol, I say, bruh, it's not a symbol. If it is a symbol, right, okay, I lost the trail of thoughts. So expression, the next one is double. Next token is double, we remove that. But that expression is symbol. So that means we have to not a symbol. Yeah, it's a best error message. I'm trying to focus to understand. Okay. So open curly, and that's it. We start in double colon. We remove the double colon. That means this thing must be symbol. So that means after double colon we have to have a head, right? We do have a head. Then after that head, we either expect the next the open this thing, so it needs to be defined by shaping. So location is that, name is from the symbol, and expression is the head that we just parsed. If it's equal to equals, we parse the next body, and then we define the body, and everything should just work, but it doesn't. Okay. So keyword is not available for whatever reason. What does it say? Moved, because it was moved. Let's actually clone it then, in both of the cases though. Please work. Expected primary. Why does it expect a primary expression though? Why do we expect a primary expression? Because I'm parsing just an expression. So, okay, here's an expression, right? So this is an expression. Then either open curly or double colon. If open curly, that is it. We just remove it and we just type it. If this thing, we check if it's a symbol, right? So, and if it's a symbol, we parse the head, right? We parse the head, and then we look at the next one. If it's open thingy, right? We remove it, of course. And I think I forgot a very important thing. I forgot to remove this thing in here. So I think that's basically what happened. I think. Yes, hell yeah, brother. So it actually defined everything. Yeah, report unexpected equal. Okay, so it's starting to... we'll probably have to like report it properly. 6, 7, 8. So expected that or that. Expected that or that. So let keyword Lexa next token, which actually implies that we probably need to do next token up front in here, right? But I'm gonna fix that a little bit later. And what we're gonna do in here, we have to return an error, and we're gonna return syntax error, I think. Syntax error. And what kind of stuff we have in here? Because we're trying to parse a command, so that means there should be something like expected command. And I removed expected command, didn't I? Yes. I think I removed expected command. Alright. So let me see. Let me see where I removed... Yeah, I removed expected command. God damn it. So now I have to bring it back, of course. Runtime error. So expected command. Right. Let's go to the compilation. Expected command. Command. Expected command, and I have to provide the token. Might as well actually just do something like this. Alright. So expected command, and I probably have to convert it into corresponding error. Is that a syntax command? Syntax command. This has to be runtime command. Though it has to be syntax command. Yeah. Okay, so what do we have here? So here we have a report. Syntax error, expected command. Print REPL lock, so this is going to prompt, then token location, and in here I'm going to say print ln error, expected command, but got token kind. There we go. Ooh, yep. And in here we are reporting stuff for the files. So this one is a syntax error, expected command, token, print ln, location, expected command, but got this thing, token location, token kind. Almost done, hopefully. Alright. So, yeah, there we go. Huh. I see what's going on. Right, I suppose it has to be something like this. Yeah. Cool. Yes, and now, if I go to 687, expected equal or something else. Yeah, so done has to be now essentially translated to that. So we need to get rid of done as well. That's very important. I suppose it's going to be the last change of the syntax on the stream. The rest of the changes are going to be done off screen. Right, so I'm just going to remove done. So there's no more done. And instead of done in here, we expect close curly. Right, so this is a close curly. What else do we have in here? Okay. So already shaping an expression, finish the current shaping with this, I suppose. Close curly. I think that's the close curly. Because it has to be interactive, right? It should be available in the repo. Okay. 6, 8, 7. 6, 8, 7. I suppose we can do something in here. So, yeah. I can copy paste this stuff and just say that expected thing. No, I actually do that in all of them. Cool. Expecting but got identifier. That's true. So now I can close it like that. So now I can do stuff like this. Like this. Like this. Like this. Cool. So this is how the language looks like now. So to make it a little bit better, maybe I can just wrap it in parentheses. I didn't think it's gonna change that much, right? So, yep. So, yeah. Dir square. We can try to interpret that thing. Dir square. So it basically expects us to have this thing, and then this thing. And now, yeah, now it works. Okay, so this one is also very cool. Dir sum. Right, it complains about that because to start shaping while defining rule, you have to do it like that. Okay, cool. So yeah, we advanced the syntax a little bit further. So now this is a valid syntax, and this is also a valid syntax. So yeah, now we have the definition, then definition of the rule through shaping, and then also just a regular shaping, and so on and so forth. So the next step is going to be basically getting rid of apply. Right, should be also pretty straightforward. So the whole change of the syntax is getting rid of the keywords and turning them from the prefix form into an infix form. So that's basically what's going on in here, which is rather interesting. Right. That is very, very cool. So I kind of want to also remove apply, because it's going to be very similar. Can we have a shape in an unnamed rule? Not right. This is a good question, finally. Yes, people starting to understand what the hell is going on. Yeah, we're gonna have shape in an unnamed rule. So essentially, you should be able to write things like all apply to an anonymous rule, right, that is formed through shaping. Why not? I mean, sure. I was also thinking that maybe not only define it like apply it through shaping, but also assign it a name, right? Square of sum, right? So here I'm defining a rule, square of sum, through shaping, and simultaneously applying it to all into the current shaping. Why not? So, but right now it's not going to work, but it is the plan. So the whole semantic and syntax is sort of designed towards being able to have these kind of recursive definitions. See what I mean? So we don't have a nested shaping yet, but at some point I'm going to implement it. Is Boolean algebra supported too? I didn't think it matters, because this language doesn't even support regular algebra. It doesn't support arithmetics at all. It doesn't distinguish between 1 and a. It is all symbols for this language, right? It doesn't care. But what you can do, you can define different rules, I would say. We can try to do that. Cargo run. So we can say something like disjunction identity, right? Disjunction identity is basically when you have false and any other thing and that thing is always going to be equal to x, right? You can define this kind of rule. Then you can go ahead and say something like false plus true, right? And you want to try to shape that thing, and you can essentially apply this ID and it will work. So right now we don't have any operators to like have logic, but in the future we're going to have, you know, custom operators. You would be able to define your own like custom operators like in Haskell. Right. But the thing about Nock is that it doesn't care, right? It operates on a level of symbols. It's a symbolic algebra. Whatever transformations you defined, like it will just apply them. The interpretation of those transformations is up to you. Mutually recursive shaping when? I don't think it will make sense, unfortunately. I'm really not sure if it will make sense. We'll see. We'll see. Maybe at some point, semantically, it will make sense, but definitely not right now. Okay, so let me see. We have that. I'm gonna run dir square. Shit. Dir square. Then sum. Okay. Then invert binary tree. It is not going to work because we expect this thing. Now it will work. The syntax becomes a little bit more cryptic, or maybe not. I don't know. It just depends. But yeah. So I also want to update readme. So we have swap when you start shaping. This is how we do that. So this is just a couple of examples. So I really like how the language starts to look more and more modern. Hopefully, let's go. So std milk. So for how long am I streaming? I'm streaming for almost 2 hours. So the only thing that is left in here is to essentially replace this with this, right? And also get rid of the reverse and essentially replace in reverse with this. So that's the goal. That's the goal. Could this language solve for another param like you? Not sure what you mean, I'm sorry. Okay, so this shouldn't be that difficult actually. This shouldn't be that difficult because it's basically the same. It's just like adding another, you know, branch in here, right? We essentially expect either open curly after expression or double colon or just bar, right? We expect just bar, and if we encounter a bar, that means this is a rule application, right? It is essentially a rule application, and that way we can get rid of the apply. So it shouldn't be that hard. I think I already developed a way to actually transform the syntax to what I want. I think I will be able to finish all of that within that stream. Pretty cryptic, but cool. I mean, Haskell is even more cryptic. Programming languages are cryptic for anyone who don't program in those languages. So I would argue that whatever syntax we had before is not less cryptic. You still have to learn it, I think. All right. Okay. We'll see. Maybe it's gonna be a bad idea to have such syntax. I'm gonna try to use this syntax for some time and see if it's good or not. But anyway. So, all right. Another thing, you know, it will all be APL law. Yeah, exactly. all of this like syntactical prettiness at some point gets you into APL, that's for sure. Okay. Update the shaping syntax. Right, I'm gonna push that right into the repo. And of course you can find the source code of this entire thing in the chat or in the description as usual. Of course. Sorry. Okay, let me see. I need to go to the Lexa, right? So we need to take a look at the Lexa. Debug Lexa. So here's the Lexa. Then I want to see if I have something like all square of sum. See, it is an invalid token. Right. Let's just go ahead and add something there. This one's gonna be bar. Do you have a grammar described in any language, for example, EBNF? Like for this language, no. Okay, so this one's gonna be. I'm gonna put the bar in here. So here's the bar. Right, so it should work. And now if I try to do something like all B, we have identifier, bar, ident, and end. Makes sense. Cool. So now, double colon. I'm not sure if that's the place where I want to do that. Double colon. So I'm parsing apply the rule. Double colon. So this is where we do that. Okay, so we parse the expression, and then depending on the next token we decide what kind of command it is, right? So if it's open curly, we start shaping, double colon, we define the rule, and now we're searching for a bar, right? We're looking for a bar, and bar is apply the rule, right? So we're trying to apply the rule. Okay, so the keyword. Yeah, the keyword will become the thing that you want, right? And this is where we have to be a little bit careful. So expression has to be a symbol because, yeah, because that's what it is. It is a symbol, and we use that symbol as a strategy name, right? So if let symbol, so this is a strategy name, expression. Something like this. So then we'll probably have to take the keyword in here. So this is the bar, we take the keyword, see if it's a symbol, and where do we say that, bruh, this is not a symbol? Okay, so this is where we're gonna say that. So do, So then we parse the applied rule after that. Alright, parse the applied rule to that, and then we just do everything in here. So should be fine. Also, in Alexa, I need to remove apply keywords. So let's go to the compilation errors. Expression. Alright. There's no apply anymore. So apply is not needed. Next one. Anything else? Anything else? Come on, we can do that. Cool. As you can see, it couldn't apply expected map, but got identifier. Right. So essentially what we have to do is to replace these things with these things. So we're applying it like that. The same goes in here. Oh boy, I wonder if that was a good idea. Is it too cryptic? I don't think it's that much cryptic. Maybe it is. We'll see. Okay, so that worked. So this is the new syntax. Right, so This is a new syntax. Isn't it cool? Now. So let's take a look at the square. Okay. The same situation. Might as well just align everything in here. Yeah. Cool. Alrighty. So this was deter sum. Binary tree. Piano. Cool. So yeah. This is another step towards a different syntax. It's really cool that I pretty much don't change the semantic at all. Right, so I'm just like changing only the visual part of this entire stuff. It's actually really cool in my opinion. It is really cool. So, and I think I can even put some things on like separate lines. I think it will still work, given how the tokenizer works. Yeah, I think it still works. That's actually pretty cool. Right. So the only thing that is left in here is actually replace reverse with exclamation mark. AST search and replace project next. Don't we already have something like that? Isn't like tree sitter about that? I don't know. So, but maybe. This project tries to achieve a very specific use case for me. I think it looks not bad, actually. I don't know about you guys, but I really like it. Looks fine. Like the general shape of the language is just like, you know, you can work with that. It looks a little bit more modern. I think maybe we should reverse curly braces for defining blocks and keep keyword shape to make it more readable. How do you measure readability? So what's the criteria of your readability? I have my internal criteria of readability, which is not something I can formalize easily, but yeah. But I don't know yours. So anyway, let me see. So A, B. So as you can see, we don't have exclamation mark. Before I can go and finish the, you know, the syntax stuff, I need to find all of the applies, right? So here is the apply, right? So here is another apply. All like this. You don't have to define a rule to use it in shaping and direct step after something like this, I guess. Update rule application syntax. All right. So the last thing that is left, again, exclamation mark. We're gonna call it bang. Bang, bang. You guys remember bang? It was think. It used to be a thing. I wonder if I ever come back to it. I'm pretty sure I'll come back to it at some point. Alright, so we never construct bang. A, B. So we do have bang now. Cool. So, and I suppose it's as easy as removing the reverse, right? Yeah. Removing the reverse, and now when I try to parse something, it's basically, yeah, I just expect bang in here, and that will automatically reverse everything. Cool. I can even do it like that. Right, it will still work. That's the point. So, examples. There's... Okay. What about some? Okay. So, the syntax of the language was completely changed. And what's funny is that we achieved all of the goals that I set at the beginning of the stream. Look at that. It is exactly what I envisioned it. Yeah. And it works, and you can, you know, interpret it and stuff like that. So that's pretty cool. I really like that. Very epic. I wonder if I can try to prove something. Right, so I always use like a square of sum. How about cube of sum? Right. First we can try to load std knock. Right, so we can load everything that we have. Let's try to define cube of sum. How difficult could it be? Right, cube of sum. And in here it's essentially a plus b cubed. Right, so it's a plus b cubed. Right, and we start the shaping, right? So the shaping is going. So what we can say in here, we definitely have an interesting thing that something cubed is essentially something squared multiplied by that thing, right? Obviously. And we can essentially apply that to the first thing in here, right? So we have the square of sum and just additional thing in here, but we already have the square of sum thing in here, so I can apply it like that, and as you can see I just expanded it. Then I suppose I can try to apply the multiplication distribution. It's either multiplication sum distribution, I think. Yeah, there we go. But that basically distributed this thing among A and B. So we take two, like this thing and multiply it by A and then multiply by B. Which is, I guess, fine. I don't see anything wrong with that. Though I would love to do that slightly differently. Alright, so I'm gonna take multiplication commutativity, right, multiplication commutativity, and I'm gonna apply it to the first one, which is not what I wanted. So let's try to apply it to this one, which is also not what I wanted, to the second one. So we definitely need something to do that. What I'm trying to do is I'm actually trying to like revert these two things. And I think I managed to do that at first one. Okay, so multiplication, commutativity, and cum. Right. So that didn't work. At some point. Aaron Kurnas 2000, thank you so much. Yeah. So I suppose maybe I'm gonna actually apply this thing in here until Maybe it has to be 0. Yeah, it has to be 0. So then multiplication, sum, distribution. And this is what I expected initially. This is what I wanted initially. Right, so this is going to be distribution. I can try to do that one more time, but I may do something like this. Sum, distribution. Yeah, this is what I want. Perfect. Absolutely perfect. You know what's interesting? At the beginning of the thing, I applied a very interesting rule. Right, so I turned a cubed into a squared a, but now I have a squared a, and I want to revert back. So maybe it would make sense for me to do... how can I call that? Cube as square, right? Cube as square. And then I can just apply to the first one, cube as square. But actually I wanted to reverse it. Yeah, as you can see, I managed to reverse that thing. I can undo it, right? So this is what I had, but then I apply it as a reversed, and it allowed me to do this kind of thing. All right, so it's like something that I can do. So next I want to do multiplication distribution yet again. Right, so it's going to be to the first one, apply multiplication sum distribution, and we managed to do that, right? Which is rather cool. I wonder if I can apply that one more time, but this didn't match. Ooh. Because I need to do multiplication commutative, but I'm not sure if it has to be, I think, second one, so it has to be 1. Yeah, I think it worked. Right, it worked. More sum distribute. I don't know what exactly happened, but for some reason it didn't particularly work. Yeah. So there will be a lot of work in here, that's for sure. A lot of work in here. This is actually very cool, because we definitely need a way to enumerate all of the matching sub-expressions so I can pick the one that I'm comfortable with. It would be kind of cool to say, okay, mul sum dist, I press enter, and it will just basically actually give me the list that I can like go down, up and down, and just select which one I want to expand and apply and stuff like that. That would be kind of cool, first of all. Second of all, what I want to do, I want to be able to sometimes focus on specific sub-expression and transform that thing. Then once I'm done, go back and maybe focus on another sub-expression, transform that. You see what I mean? The feature of focusing, because the expressions may start to grow really fast, very quickly, and sometimes you just want to focus on that small sub-expression and transform that, and then go back and transform like a bigger one, and then go back, and so on and so forth. Maybe we'll have a way to like literally focus on the nth sub-expression that matches that specific pattern. Something like that. So yeah, but by just using this tool, I'm starting to get ideas on how like we can improve that and what kind of extra features we can add. It would be extra progress if it would highlight on the line itself which match would apply the thing. Yeah, so, and not only highlight, but like use the colors in the terminal, like highlight with the colors in the terminal. So I can probably depend on some package that gets, you know, cross-platform highlighting or cross-platform colors and stuff like that. That will be interesting. So moving in that direction is definitely something interesting. So yes. Like select sub-expression and work on it, yes. That would be kind of cool. So something like select, I don't know, a multiplied by b squared, right? And it will find everything that matches this, and then I can say, okay, this matches this sub-expression. Let's focus on that thing, right? So that would be kind of great. because it is okay with the small sub-expressions, with the small expressions, but once they start become bigger and bigger, it's just like difficult to focus on certain things. So yeah, okay. I guess that is it. I need to commit. So let's say update reverse syntax. Right, I'm gonna push that right into the repo. You know where to find the source code, and I guess it is time for me to go. Does anyone have any questions, by the way? Does anyone have any questions? No VTuber. Is there any chance of VTuberness soon? No, this is a programming channel. We're doing programming here. Are these going to be on YouTube eventually? They're going to be on YouTube. We have quite a few episodes of NOC development and do plan to upload them on YouTube, yes. Alright, so that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Thank you, Luke, for 4 months of Twitch Prime subscription. Thank you, thank you, thank you. And I see you all next time. Love you.